So with the test last class period, we have no homework to check, no warm-up to do. We're going to continue on with 7.1. It's going to continue on with quadratics. Take it a step further. Some of you asked last unit, when are we going to factor? Are we going to have to factor? How do you go from standard to factored? That's going to be a lot of this. How do you know what the signs are, if they're positive, negative? But there are 24 lessons here, so this is going to take us a majority of our remaining time. Hopefully we can work in a couple projects as well. But the first question, Jackson, would you read it, please?
A mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground, with an initial vertical velocity of 92 feet per second.
Continue. Yeah.
The function ht.
You don't have to read it. Just continue.
The function models the height of the potato over the ground in feet, t seconds after launch. Do I start reading questions?
Yeah.
What is the height of the potato 1 second after launch?
All right, so if we look at 1 second, we could probably guess. I want an exact number. Anybody know how we'd get that versus typing it in and just saying, look at Desmos?
You plug in 1 into T.
Yeah, plug in 1 for the time. So we're going to figure that out. Nice thing is times 1 should be super easy. 1 squared times negative 16 is just negative 16. 92 times 1 and 20. So 92 plus 20 minus 16. 96. So that is 96 feet. You could also label it right on the graph. Eight seconds after launch, will the potato still be in the air? How do you know? Clearly lands before 8 seconds. Will the potato reach 120 feet?
Yes.
If so, when will it happen? Yeah, it happened twice.
4.5.
4.3 and 1.4.
Yeah, hard to know exactly, right? Could plug it on or into Desmos and find out exactly. It's actually 1.4 and 4.3. Reaches 120 feet on the way up and on the way down. When will the potato hit the ground? About 6 seconds. All right, we're going to skip 1.2 because 1.3 talks about something really similar with a little more detail and even a picture here. Ken, read it please.
A teacher will give you a picture that is 7.
1.3, please.
Here's a diagram that shows the picture of the frame that is the same distance all the way around. The picture is 7 inches by 4 inches. The frame is created by 10 square inches. The frame is created in the form of a rectangle measuring 4 inches by 2.5 inches.
All right, so you know that the picture is 7 by 4. That's the actual picture. So this is 4. This is 7. Now the key is it's the same thickness all the way around. I have no idea what that number is. So since it's unknown, I'm just going to put an X. That means this width is X. You know, everywhere you look, it's the same. So however you need to diagram that, but the frame is an unknown, we don't know it yet.
Then what's the 4x2.5?
It says the frame is created 10 square inches of, so it tells you how much material you make there. We're gonna get to the 4x2.5 here shortly. Okay, it says write an equation to represent the relationship between the measurement of the frame, picture, and of the frame, and the area of the entire framed picture. Okay, so area of the whole thing would be the area of the picture plus area of the frame equals the total area. Okay, so what is the area of the picture? 28. Area of the frame? Tells you the frame, that's what you mentioned, Caleb, up above. It's 4 by 2.5. 10, so our total area is 38. And so we're gonna use that.
Would the inches square or?
It would be square inches, yes. All right, so now I want to figure out the area of the whole thing algebraically. So I would like to know how far it is from one side to the other. Top, bottom, middle, it doesn't matter. It's a picture frame, so it should be square. So how far, if I draw a line straight across here, is that? You can't give me a number, but you can give me an expression. I said, how far is it from that dot to that dot?
9.5.
Okay, well, how far is the picture?
7 inches.
And what do we got marked for just the yellow? X. So 7 plus 2x, there you go. Because it's x and x, so it's 7 plus 2x. This is area of the frame pick. All right, so that's the length. So what's the width?
Four plus 2x.
4 plus 2x. Should be times, length times width equals area, and area you told me before was 38. Is that factored or standard? That is factored form. So just as a review, I'd like you to FOIL that. Use a diagram if you need to. Just see what you get. Just multiplying those two things in parentheses. Draw your arrows, FOIL, or draw a diagram. What's that? That's fine. You can always put it in the right order as soon as we get all the numbers. Okay, combine like terms if you can, and put them in the right order. Remember, it should have a square term in there.
I'm confused what 4 by 2.5 is representing in my picture.
Just how much material you use for the frame.
So like the yellow part, tank part,
So that's using 10
square inches.
square inches of material. We don't know exactly where the 4 or the 2.5 is. Basically, you had a scrap put piece of wood laying around 10 square inches and you cut it to make it fit nicely. All right, everybody get a chance to do that? So I'm just going to FOIL quickly. Hopefully you get the same numbers, 28, and then I got a 14x, and then I got an 8x, and I got a 4x squared. Correct order and combining like terms. Would look like that. And then that still equals 38. So this would be standard form. This would be factored. So just out of curiosity, it says, what would a solution to this equation mean in this situation? Well, the solutions will give you the possible width of frame. So I'd like us to go into Desmos, type in either the factored or the standard. It should be the same thing. To figure out what we get for a solution. It's not asking us, but we're going to add that to this problem. So Desmos, type her in.
Oh my goodness.
Yeah, so type the parabola on there, then type y equals 38, and see what they mean. Now you should see 2 zeros, one should be negative, right? We don't care about that one. Strang, you got an x value?
0.422.
So I don't care again about the x one or the negative one, I only care about the positive. So 0.42 inches is how big that frame would be. It's not asking you that, again, that's just what we decided to go for. And find it. Remember, anytime you see a negative, parabola goes upside down like a ball getting shot, right? Even think of shooting a basketball. It's a parabola, it's upside down, it's coming down. Tossing the ball up in the air, you will see that a lot. So negative 16, remember, has to do with gravity. So that's it actually for the new stuff today. Not a lot that was actually new. Take a look at the homework, see if there's anything in there that's
Can you go over the last problem on number?
too crazy. No, most people haven't even read that yet. Yeah, pretty self-explanatory. Again, watch for the word all or explain. Please do that. So just 1 through 7 for tomorrow, whether we are here or virtual.